937. That is the number of galaxies the James Webb Space Telescope just found glowing in a way that, according to every model of galaxy formation we have, should not be possible. These are not anomalies you can explain away, not noise in the data, not one or two strange objects at the edge of detection. 937 galaxies doing the same unexpected thing. And every week that Webb keeps looking, that number grows. 5 things the Webb found that push our models to their limits. 5 problems cosmology has no answer for yet. And one question that changes everything. Everything in this video comes from peer-reviewed research published in 2025 and 2026. The papers are real, the numbers are real, and the scientists involved are not fringe researchers. They are at MIT, Northwestern, the University of Texas. Here is what they found. In 2026, a team at Northwestern University published a study that should have made headlines everywhere. They analyzed James Webb data and found 937 galaxies in the early universe, whose gas clouds are outshining the stars that power them in specific wavelengths of light. Think about what that means when ultraviolet light from young stars hits the gas around them. That gas absorbs the energy and re-emits it, mostly in a narrow range of colors astronomers call emission lines. In these 937 galaxies, those emission lines are so intense that when you look at those specific wavelengths, the gas outshines the stars themselves. It is like looking at a city through a thermal camera. The heat from the buildings glows brighter than the city lights, except here the heat is ionized gas, and it is far more intense than any model predicted. The researchers call this excess nebular emission, and the explanations they have are all uncomfortable. 1. These galaxies formed stars hundreds of times faster than any model allows, which means our understanding of star formation in the early universe is significantly incomplete. 2. Something else is powering the gas, not stars. A different energy source, possibly supermassive black holes feeding on surrounding matter, active galactic nuclei hiding inside what we thought were normal galaxies. 3. The early universe was far more active than we assumed. Not a quiet, gradual place, a furnace. None of these explanations break the laws of physics, but every single one of them breaks our models of how galaxies form. In January 2026, NASA confirmed something that pushed the limits even further. A galaxy called MOM-Z14. It existed just 280 million years after the Big Bang. To understand how early that is, the universe is 13.8 billion years old. 280 million years is 2% of that. If the universe's entire history were compressed into 1 year, MOM-Z14 existed on January 4th. But MOM-Z14 was not just early, it was chemically evolved. It had already formed multiple generations of stars that lived, died, and seeded the galaxy with heavy elements. In 280 million years, when every model said the first stars were barely beginning to form, Rohan Naidu of MIT, the lead researcher, said it plainly. With Webb, we are able to see farther than humans ever have before, and it looks nothing like what we predicted. Nothing like what we predicted. Not slightly different, not close, nothing like it. This does not mean the Big Bang is wrong, it means our models of what came after, the timeline of galaxy assembly, the pace of star formation are far more incomplete than we thought. In early 2025, astronomers discovered a galaxy with a perfect spiral structure within the first 2 billion years of the universe. They called it the Big Wheel. And this is what makes it so hard to explain. A galaxy that massive, that early, should be an elliptical, a formless collection of stars with no clear structure. The violent mergers and collisions that dominated the early universe should have destroyed any spiral before it could form. But the Big Wheel has arms, graceful, organized spiral arms, exactly like the Milky Way, as if the universe skipped 2 billion years of evolution. It is a poetic description, not a scientific one, but the image it conjures is close to the truth. The early universe was assembling complex structures far faster than any simulation predicted. Dr. Themia Nanayakara of Swinburne University studied it. His conclusion, either the Big Wheel grew in relative isolation, somehow avoiding every collision in a crowded early universe, or most of its mass formed from within, in a way we do not yet understand. Neither explanation is satisfying. Both require something new in our models. James Webb discovered objects that should not exist so early in the universe. Compact, red, extremely bright in infrared. Some appear to contain billions of solar masses less than 1 billion years after the Big Bang. That is the problem. Black holes grow by feeding on matter, but physics sets a speed limit, the Eddington limit. Even growing at the maximum allowed rate, some of these objects should not have reached that size in time. There simply was not enough time. Now, the mass estimates are still uncertain. Some of the brightness may come from active galactic nuclei, making them appear heavier than they really are. But even conservative estimates leave the same conclusion: too massive, too early. Some researchers suggest these black holes form directly from collapsing gas clouds, but even that struggles to explain their size. Either our models of black hole growth are incomplete, or something in the early universe worked differently than we thought. The crisis goes beyond galaxies and black holes. There is another problem: the expansion of the universe itself. Using the cosmic microwave background, scientists measure the expansion rate at 67 kilometers per second per megaparsec. Using nearby supernovas, they get 73. Two methods, one universe, two different answers, and the discrepancy is now at 5 sigma, the same confidence level used to confirm the Higgs boson. This is not supposed to happen. Either one method contains an unknown error, or the universe behaves differently than our models predict, and the tension is getting worse, not better. Is the Big Bang wrong? No. The Big Bang itself is still strongly supported by evidence. The cosmic microwave background, primordial elements, galaxy structure, and cosmic expansion all match observations. What is in crisis is our timeline of the early universe. James Webb is revealing galaxies, stars, and black holes forming far faster than our models expected. The universe was not as slow and chaotic as we thought, and every major telescope in history has forced science to revise its models. Webb may be doing it again. Here is what should keep you awake. James Webb is barely getting started. Its primary mission runs through 2027. It could be extended to 2035. Every new observation pushes closer to the Big Bang, and many of those observations confirm what the models predicted, but some of them do not. The ones that do not are not footnotes. They are 937 galaxies. A galaxy that existed before stars should have had time to form. A spiral structure that should have been destroyed. Black holes that grew faster than our models allow. A universe that gives two different answers about how fast it is expanding. We are not discarding a model. We are discovering that the model was an approximation, and the reality underneath it is far stranger than we imagined. The universe does not owe us an explanation, but it is giving us one anyway, and we are only beginning to understand what it is saying. If this video made you question what you thought you knew about the universe, subscribe to Untold Universe. Tuesday, Thursday, Saturday, every week.